Okay, in here we are given a function, and this function is a slope function with a constant p that we do not know. And we want to find that p, and we want to therefore find that function. We're given a few values here of the function when it's 0 and it's 1, and also we're given when that function is 2 pi. The first thing that we need to do to find the function would be to integrate the slope function. Because it's a trigonometric function, and this function has inside here a composite linear function. Let's just highlight that so that you know that that is a composite thing. We can now integrate it according to trigonometric rules. And on the right here, I just rewrote that rule. This p over here is just a constant, and we do not need to include it in the integration. So what we'll do is just put it outside and rewrite our integral so that it's just with the sign. And so p out with the minus sign in here, and 1 over a half, because a is a half. And we finish off with a cos a half x, not to forget the d, plus c. And that will be just minus p to cos half x. And I know you might be frustrated with the fact that I'm going so slowly through every single detail, but I just want to make sure that you understand what's going on. You can just miss those steps and go straight up to the bottom line. Okay, so this is our function fx, which is equal to minus p to cos a half x plus c. And you'll notice that we've got two constants in here. One of them is a p, and one of them is a c. And we cannot write the proper function without first solving for it. How are we going to do that? Well, we've got extra information. We know that f0 is equal to 1 above over here. So we just substitute the 0 in where the x is. So that'll be 2 cos a half. And the x is 0, so we'll just write 0 plus c. So we know that cos 0 is equal to 1. We can figure that out from using the GC, the calculator. That means that our cos 0 here just ends up being 1. And all we need to do is rewrite this again. Okay, minus 2p plus c. That is equal to 1, as it stated above there, for f0 is equal to 1. We were given that information up here, that that is equal to 1. And therefore minus 2p plus c is equal to 1. And this can be our first equation. We'll call it number 1. Now from the other information, we know that f2 pi is equal to 0, so we could do the same thing and substitute it one more time into our fx equation, just like we did over here. And we have minus 2p cos, this time we will have 2 pi on 2 plus c. So what is cos pi? And cos pi is equal to negative 1. So we'll just substitute 2p times negative 1 plus c. And that's short for 2p plus c. And if we look up, we remember that this was supposed to be 0. It's equal to 0. So we'll write it again. Therefore, 2p plus c is equal to 0. And that is our second equation. And I have two simultaneous equations that I need to work out. I'll just rewrite them here. That's one of them. And the other one is 2p plus c is equal to 0. There are various ways of doing this. I'm going to add these two together so that minus 2p plus 2p cancels out, and c plus c is 2c, and 1 plus 0 is just 1, which means that c is equal to a half. If you have another way of solving this, please do, as long as you get c is equal to a half. Okay, if I substitute the c is equal to a half in this particular second function, I will just get 2p plus a half is equal to 0, which means that 2p is equal to negative a half, which means that p is equal to negative a quarter. I've rewritten our function up here, remembering that it has a negative sign in front of the p. If you lose that, we're going to get a mistake. So let's just continue. Substituting, therefore, a minus with a minus a quarter times 2 cos a half x plus c is a half. So in that case, what we have is a minus and a minus becomes a plus, and 2 and a 4 will cancel down. So this is just going to be a half cos a half x plus a half. So I'm satisfied with that answer.